Hello everyone. Today we will discuss a problem concerning the motion of two masses that are connected through a string and hang over a pulley. Let's read the question together and try to understand what's being asked. Two blocks are connected by a string and hang over a pulley as shown in the figure. Given the masses of the blocks are 2 and 4 kilograms. First, find the acceleration of the blocks. Second, find the tension force in the string connecting M1 and M2. So we have to find the tension force in this string. Okay, let's try to do the first part and find the acceleration of the blocks. Before we find the acceleration of the blocks, let's establish in which direction do these blocks move. Since M2 is a heavier mass than M1, the blocks should move in the direction of mass 2 as shown in this arrow. Next, let's find the forces acting on the system. Well, the forces are the weights of these masses. So the force acting on the first block is going to be M1G, and the force on the second one is M2G. Now, how are we going to find the acceleration for this system? Well, we're going to use Newton's second law, which states that net force has to be equal to mass times acceleration. And what is the net force in this case? The net force in this case is going to be M2G minus M1G. So we're taking the direction of the motion to be the direction of the acceleration, or the direction of the net force as well. So M2G minus M1G, because these weights pull in opposite direction. And this has to be equal to mass times acceleration, and mass is M1 plus M2. From here, we can easily find the acceleration to be in this form by dividing both sides by M1 plus M2, and by substituting the given values of the masses, we find acceleration to be equal to g over 3, or 3.3 meters per second square. Now, let's calculate the tension in the string connecting these masses. For that, we're going to just consider, let's say, one of the masses. Let's choose mass M1. What are the forces acting on this one? The forces acting on this one is its weight and the tension force. And these forces are acting in opposite direction because tension is pulling on mass 1, and under the influence of this tension, this block is moving up. So the net force here, net force on mass 1, will be equal to tension minus M1G, which is the weight. And this has to be equal to mass times acceleration. And the mass is the mass of the first block, which is M1A. From here, I can easily find that tension is equals to M1G plus M1A, or factor out M1 and have M1 times G plus A. Remember that the acceleration was equal to G over 3. So by just substituting G over 3 instead of acceleration, I find the tension force to be equal to 4m1 G over 3. And again, by plugging the mass and the value of the gravitational acceleration, I obtain the force to be equal to 26.1 newtons. So you may ask, okay, why did we consider mass 1, not mass 2? Well, that's a valid point. Let's do it for the mass 2. Again, this is how we did it for the mass 1, and now we're going to do it for the mass 2 and see if we get similar or same value. Well, again, what are the net forces acting on mass 2? Well, net force on the mass 2 is going to be the weight of the mass 2, which is m2g, downward direction or in the direction of the motion, and the tension force, which is going to be opposing this motion. So the net force on mass 2 will be equal to m2g minus the tension force, which equals to mass times the acceleration. And in this case, mass is m2. Well, by just moving m2g to the other side of the equation, we obtain this expression, and from here we can find the tension between mass 1 and 2 to be equal to m2 times g minus a. And again, we already know what the value of acceleration is, so just we plug in g over 3 instead of a, and we find the tension to be equal to 2m2g over 3. And if we plug in the mass of the second block here, and then 9.8 meters per second squared for g, we find the force, the tension force, to be equal to 26.1 newtons, which is exactly the same value that we found when we only considered m1. I hope everything here is clear and this video was helpful to you.